Yes, I have returned. I have returned with the loud power supply fan as well. That will be remedied in another episode of this series. But the good news is, I got the audio issue resolved, and it came down to a couple of bad traces on the board. And I'll show you the process of how I figured out what was going on with that, and how I repaired it. So, as I will show you right now, we do have fully functional stereo audio, no distortion, the way it was meant to be. Now I will hit F5 and turn up the volume a bit. As you can hear, everything is excellent. Everything works. I can disable one channel and then the other, and of course now we have nothing, and then turn them all back on again. So everything is fully functional with no distortion. And like I said, I will show you what I found and the tools I used to reach those conclusions. So I shall be right back. Yes, so here is the repair that I have done. This is the area, this is the audio output circuit. There's a quad channel op amp here, and this tested out fine. All the inputs and outputs for all the 4 channels were working fine. And this is the main output for the left and right, or should I say left and right, stereo jacks right here. So the issue was on this chip. Now the chip itself was fine. I did remove it for testing purposes and put it back in again. Basically testing so I could test all the pads and connections going to it without the chip in circuit. It's a lot easier to do that. Of course I put it back again. But all the issues were coming from this chip. So not the chip, I should say, from the pads, the traces. There were 2 broken traces that I found. And one of them here, you can see this, if I can get down close enough, there's a bodge wire that I put in here onto this capacitor, which goes from the positive of this capacitor to the feedback resistor here. Because this was missing, the feedback resistor wasn't in circuit on this op amp, and because it wasn't here, the amplification was insane, like a very high amount. That's why you heard the distortion. So I initially fixed that wire. I was kind of saddened because what happened was when I plugged it in, okay, I didn't get the distortion when I ran the audio test on the Amiga test kit, but I got nothing. So once again, I used a basically an audio probe. So it's basically just a probe that I used to see where the audio was coming. That's why I knew all the audio inputs and outputs were fine on here, and all the audio inputs were fine here, but the outputs were having a problem. So like I said, I fixed the one bodge wire. That fixed the issue with the gain on this chip, but there's no output. So once again, using my audio tracer, I found that all the signals were coming out of this, but it wasn't making it to the right jack. And that's why you'll see there's a bodge wire here, and it runs to under the board to, of course, the other resistor that the connection broke to is on the other side of the board. So I just ran that from here under the board to the where the trace connects to the resistor on the other side, and I believe it's a 1K, and voila, it works. It works just fine. So I will show you how I came to this conclusion and the tools I used to get to that point. And hopefully I will not bore you to death, but regardless, the show must go on. I will be right back. Oh, and one thing, I almost forgot to show you. This is the board recapped. Memory in place, the battery backed up clock module is in place, fully works perfectly fine. I put this plate here back on, but as you can see, all the caps have been replaced and they're nice and shiny, very clean solder connections. And like I said, unfortunately, the leaky caps here is what caused the audio problem, and this is quite common. If you find an Amiga 4000 motherboards, a lot of time there will always be corrosion on these audio caps. I do not know why. I know these were the cheaper ones I mentioned before. They were set on nice black markings for the negative terminal. They will be a light gray. Those ones are problematic. Now all of them, regardless, leaked. They just seem to leak the worst, and this is what caused the audio problems. But enough of that. As you can see, everything looks really good, and I will be right back with the troubleshooting steps I took and the tools I used. Okay, the troubleshooting process should always start at the power connector. And I'm pretty sure everything was fine because the computer did power on and it booted up and whatnot. But this is the connector on the A4000 motherboard. And it just shows you that you have your plus 12 volts, your negative 12 volts, your power okay. That's sent from the power supply to, you know, it's saying, yeah, I got the correct voltage. You can power up. And then the plus 5 and of course the 2 ground here. Everything worked fine, everything tested fine, everything was like just like 11.9 volts roughly, that was 4.9 some change, and everything looked really good. And this I just grabbed off of a quick eBay search and pulled up a picture and of course printed it out in this very high-tech slideshow that I'm doing here. So I knew the issue was somewhere to do with the audio amplifiers, or the op amps. There was 2 of them. Nice green background there, sorry. Oh, I hit the tripod again. Okay, get that out of there. That's for later. So the LF47, that's the 14 pin, maybe. There we go. Is the 14 pin op amp IC. So you need to know, you know, basically the pinouts so you can do your testing. So I made sure we had the plus 12 and negative 12, which we did. And everything else seemed fine. Like I said, I used my audio tracer and I was getting signal on all the outputs, and I was even getting signal on all the inputs as well. You got the inputs here, but basically I tested the outputs. So I had signal here, here, and here. So I knew I was getting all 4 channels, no problem. Because remember, there's 2 channels, you know, per channel, if that makes any sense. The pole has 4 channels, so you get 2 for left and 2 for right. So anyway, these tested fine. So I know that was okay. And then I moved on to the chip that was having the problem. Now I keep saying the chip that was having the problem. It wasn't the chip, it was the connections going to this chip that was having the problem. And I am doing a really good job here. Thank you. I'm sorry about that. So here, the inputs tested fine. So I was getting signal there using the audio tracer. But the output was fine here. And now this is like the stereo. Remember the other one had the 4 channels? This combines it into stereo, so you're just going to have left and right. That is it. So you just have a dual op amp versus a quad. Because the quad, remember, was handling all 4 channels from the Paula chip. This one is now just going to do the stereo output. Basically mixes it together. So what we're going to do here, or sorry, what I have done, I had audio here, and I had extreme distortion on output too. So, you know, right off the bat, oh, it's a chip, replace the chip. Well, we have to figure out what's going on here. So what I did was I pulled up the schematic for the Amiga 4000 right here, and I'm going to have to hit the tripod and then zoom out. Make sure I have to do it in that sequence. One here, okay, there we go. Bit of shadows happening here, I'm sorry. If I can get this thing somewhat lined up. Maybe I should edit this out because this is craziness. Okay, there we go. So, as mentioned before, using the audio tracer, basically it's just I used my amplifier for like the speakers that you heard earlier, but I used one of the basically the RCA inputs and put a capacitor on there so I can test each of the pins on these ICs to see where I get audio. It's a quick and easy way to do an audio test. Make sure you use the capacitor though, because if you don't, you're going to have horrible things happen. The capacitor basically blocks the DC voltage and only lets AC pass, which is of course DC you do not want in audio circuits at all. Bad. But anyway, so voltage is tested fine, like I mentioned earlier, on this chip and on the other one as well. But this is right here. This is the quad op amp, the LM347. And it's the one that handles the 4 channels. So there's quad means 4 channels from the Paula chip. 2 channels per channel, if that makes any sense. Okay, so don't need about a check mark. I had audio here, audio here. I had clean audio here, clean audio there. So this confirmed that all 4 channels from the Paula chip were fine. They were good. They were good to go. So I know this chip was okay, and all this circuitry in here was okay. I wasn't sure about the filter circuits, which are down here, but we tested that later in a Amiga test kit. Everything's fine. So as you can see here, this is where some action happens. So using the audio tracer, I had good clean audio here, I had that extreme horrifying distortion here denoted by the X. So there's the stereo output here, chip, which basically, you know, mixes these 4 channels together to left and right. It had a problem. So the voltage is tested fine, so that's good. And then I started testing between, I guess it's pin 1 and 2. And there's a 4.7K. This is your feedback resistor. This is what tells how much gain to have. Like I said, if this is open, it'll be infinite gain, which will, well, not infinite, but to the point of distortion, and it's not usable anymore. But it's a 4.7K resistor. So I measured 4.7K across here, you know, across 1 and 2. But when I went to pin 6 and 7, so I measured here and here, I was getting like 8 mega ohms. So basically an open circuit. So that's why there was so much distortion here, is because this thing was open and this amp, this side of the amp, this channel was running at full gain, and it was just distortion. So I knew there was an issue there. So there's a resource site, and I'll give you the link in the description. There's, or the comments, or both, I don't know. But anyway, it's a Amiga PCB Explorer. And they have multiple, like, you know, computers like Amiga 2000, 500, 600s, 4000s, CD32, and so on. So I got this here. I can zoom in a bit. Am I in autofocus mode? Yes, I am, because I never know. And let me make this not look so askew. So I knew the problem was here. So what I did is I used my continuity tester. And these are the 2 pins here. This is 6 and 7. So that's 4, 5, 6, and 7. 6 was fine. I could follow the trace back to its test point. It's actually one of the resistors. It worked just fine. I believe it's the one down here. But this one here, if I went to the resistor, which was a 4.7K, there's nothing. But if I went to here, which is the, that would be the positive side of the capacitor, I had continuity. So I had continuity all the way through here, but not to the feedback resistor. That's why the gain was just insanely high. So I basically ran the jumper wire from, you know, the positive end of the cap to this resistor, and that completed the circuit. And, and that fixed that problem. So I thought, great, we're fixed. Everything's going to be awesome. But it wasn't. I didn't have distortion, but now I didn't have anything. And probably the reason why you heard the distortion is it was so high that sometimes you get leakage current, because the gain was so high that just feeds back into the channel that, you know, was dead. So it's kind of hard to explain, but it was just so much signal that it was just bleeding into the other parts of the circuit. So when I got it fixed, there was nothing, of course, because there was another problem with that. And that I can show on here as well, which I haven't added. So I had a signal, so I wasn't getting anything output on the right channel here. So, okay, so there was nothing here. And no audio. Audio here, yes, that was fine. So the problem is now I used my audio signal tracer again, my audio tracer, and I was getting output here. But I wasn't getting output out there. So I'm thinking, well, there's this 1K resistor that goes up here and connects to another 1K, but the whole point is it goes all the way through this ferrite bead. Yes, it's not a fusible link, it's just a ferrite bead. It's just for noise suppression. And it connects to the channel. So lo and behold, the connection from here to here was also severed. And that's when I ran the ferrite bead, the jumper wire from the top of the board, underneath, and then connected it to this point. And that fixed it. And that is a patented high-tech slideshow explanation demo. Yeah. And my camera is about to overheat, apparently. So before it explodes, I'll see you in a moment. Okay, now that my camera has cooled down, so I'm going to show you how, I keep on mentioning audio tracer, audio tracker, audio something. It's really simple. This here is simply the inputs to my amplifier. As you can hear. Oh, sorry. Lots of noise. Of course, I have the volume cranked, but yeah, that's the audio inputs. And I have a cable that I threw together. So this basically connects to here. It doesn't really matter, left or right. It's irrelevant, and because it's going to come out of one channel anyways, or both, I should say. And then here I have the fancy, so I'm just using, there was actually 2 wires in here because it's stereo obviously, but I don't need that. So I'm just using the one for ground and not using the other channel. And then the other channel here, the separate wire, I have a capacitor. It's a 10 microfarad. Anything should be fine. 10, 22, 47 is fine, even a 1. But this is a 10 microfarad cap. The polarity doesn't matter too much for this purposes, because the main thing is it's, regardless, is going to block any DC voltage from getting into my amplifier, which it may not care for. And that's it. So what I'm going to do with this is this end here, which is just the braided ground, which connects to the ground on both of these. So I need to ground this. So, oops, sorry. That was predictable, wasn't it? Oh no, my ground point that I used, I covered it up with stuff. Yes, give me one moment, I'll be right back. Okay, I took out a jack screw. This is how before I didn't have this plate on here for the mouse port and stuff. So I just basically have it tied to ground. You can use an alligator clip or just any ground point is fine. So now that's grounded. And now now we're ready for the testing. So I got that grounded, and this now is ready to do some probing. So I'm going to turn the power on. And yes, I can't wait to get that fan replaced with maybe a Noctua or something like that. Okay, now right now the amplifier is not hooked up to the computer. Only way it's going to get audio is through here. And I'm just waiting for the timeout for the IDE interface. They're looking for boot drives, and it's going to boot off my floppy. And we'll try the, I'm going to run the AmiTest audio, like I did at the beginning of this part of the video, and we'll probe these points I was talking about. Okay, so it's good to go. The keyboard is not connected, but the mouse is. 1 second. Okay, there we go. Just one moment. I need to get my other pair of glasses for this. Okay, so the thing is, before I didn't have a camera pointing at this. Maybe I'll do it from this side so I can see better. If I can get this to work better. That is better. Oh, I am trying to reach through the tripod again. Oh, I'm not going to use my left hand. I'll be asking for it. This is awkward. I'm sorry. Okay, so this is the quad amp, op amp here. So we should have audio here. Or not. Do I have the volume all the way down? Yes, I do. Okay, let me try that again. So this is pin 1. Okay, it's intermittent contact, but I'm fine now. So that's one channel from the Paula. And then we have 7. That's the other audio channel. And then we have 8. That's the other audio channel, so we're at 3 from the Paula. And then 14. So right there, before the repair, that works. So that proves Paula's fine. This op amp is, quad op amp here, is running perfectly fine. Now this is a stereo output IC. It mixes the 4 channels into 2. So what we're going to do here is, I believe, pin 1. Let me double check. Make sure I don't do this incorrectly. Pin 1 and pin 7. That's your stereo output. So before the repair, I had audio here, which I do. So this is going to mix 2 of the channels together from the Paula, and then I had pin 7. So it's 1, 2, 3, 4, 5, 6, 7 is right here. Okay, and before I had horrible distortion, and then after the first bodge wire that I replaced, then I had nothing. And that's just because the signal wasn't being passed through here. The only reason why I heard the distortion, like I mentioned before, the gain was so high, it was leaking through into the other part of the circuit here. But so as you can see, it's fully functional. So that's all this audio probe is that I'm doing. And it's good. It's an analog way to figure out why the audio is not happening. Some people use oscilloscopes. I do have one. But this is easier because it's direct confirmation. Yeah, I got audio. So there we go. That's my hand's probably in the way horribly. That is basically how you make one of these. It's pretty simple. Yeah, that's it. I'm not going to go into too much detail about this. But anyway, that's that. That's how I figured out the issue. And then the rest, I used Amiga PCB Explorer, like I mentioned before, that printed out that nice green picture like that, so I knew what traces to look for. This doesn't show the other trace that I had to put on, whatchamacallit, from right here. I need a pointing device. Oh, my pointing devices are in short supply. It's under the tripod. Yeah, oops. That was to be expected, wasn't it? Okay. Yeah, the other connection. I'm going to get in the way here. Whew. Let me see here. Let me zoom in a bit, shall we? That's very zoomed in. Yes, and you can see it. And that's the connection here that I added. Right there. That one solved the gain problem. Put this resistor under here in circuit to get this happy, so the gain's not all over the place, like extremely high. And then the bodge wire from here to under the board that connected to the one side of the 1K resistor where that trace was broken. So yeah, that is that. So that wraps up this episode. I know it was a bit longer than I expected it to be, and hopefully you endured it to this point, but I wanted to show you some of my troubleshooting steps using the audio tracer and all that fun stuff. And of course the Amiga PCB Explorer comes in very handy, so I can figure out what part goes where, and easier to trace. Continuity meter, bam, you're done. And it's not too bad. It took about 3 hours to get through the process, but you know, I didn't replace parts that didn't need to be replaced. But definitely, you get any aboard Amiga 600, anything at surface mount capacitors, so 600, you know, 4000, 1200, whatever, replace them, because even though they may not look bad, they probably are, and definitely near the end of their life. And no, it's really good. This board is in really good shape. So in the next episode, what we're going to do is do the retrowriting of the case, so the front plate, and then cleaning up the keyboard. Obviously, that's going to be the biggest challenge, I think, and then also cleaning the top metal cover as well. And then the episode after that, we're going to do various upgrades, and so this will be installed the case. I'll probably replace this with an 060 version. I'll show you at that time, and various cards, add-in cards on the riser port. So enough of that. I'll join you in those episodes. But if you like this video, please give it a thumbs up. If not, you know what to do for some reason. And yeah, and please subscribe, because it shows me that you guys actually watch my videos. So thank you for all the subscribers I do have at this point. So there's more content to follow. I know it's oh yeah, one other thing I almost forgot. Please you know, click on the notify, because my videos are rather random, so that way you know that at least I produce something for you to watch. And yeah, that's pretty much it. So as I always say, as always, thanks for watching.